Today we will be presenting our proof for problem number 8. The participants of this project are Cadet Hogue, Cadet Jackson, and myself, Cadet Taylor. First off, what is a proof? A proof is an inferential argument of a mathematical statement. In other math courses, the goal is to solve a problem and get a tangible value. However, in this course, our goal is to articulate an accurate and clear statement and why that argument will always work without any sort of doubt. For example, in other math classes, the objective would be to find an actual value such as 2 pi. However, in this class, our objective is to prove why the answer is 2 pi. So the intent of this class is to take individuals who can use mathematics and develop those individuals into people who understand mathematics. So there are different methods for proofs. There is a direct method, which means A means B. For this proof, we're going to be using conjunction. Contrapositive, if A then B, means if B then not A. Contradiction is if A given B, then not B means A. And inductions, if P of 1, the base case, is true, and P of k plus 1 is true, then P of n is true for every positive integer.
How to prove. Understand the question being asked. Know what a limit is. Second, we will define what we know and need to show. And third, we'll use work in algebra to show what we're trying to prove. Suppose that the limit as x approaches a, f of x equals L, where L is greater than 0. Prove that the limit as x approaches a, the square root f of x is equal to the square root of L. We know that if the absolute value x less than a is less than delta, then the absolute value f of x minus L is less than epsilon. We want to show if the absolute value f of x minus L is less than epsilon, then the absolute value square root f of x is less than the square root of L. It's less than epsilon. And here's our proof. We're going to let epsilon be greater than 0. Again, show that the absolute value f of x less than minus L is less than epsilon. From the absolute value, the square root f of x is less than the square root of L. We will do that by using the conjunction method in our algebra. So first we start off with the expression absolute value square root f of x is less than the square root of L. We can show that that is equal to that multiplied by its conjunction. And doing so, we get rid of the square root on the numerator, and we have the conjunction on the bottom. We can say that that is logically less than or equal to f of x minus L over the square root of L, and that's important because we now have this in our expression, and we can logically say that this is less than epsilon divided by the square root of L. So then if we just multiply the square root of L on both sides, we get this. Therefore, by the conjunction method, the limit as x approaches a, the square root of f of x is equal to the square root of L.